And my thesis is there is no other industry in the United States that's in the same situation where you are expecting people to increase their output, but actually handcuffing them by saying that they have to continue to use a process that hasn't literally taken advantage of the technological developments, let alone of the last 100 years, but even of the last 10 years.
This is the Construction Leading Edge podcast from constructionleadingedge.com. My name's Todd Dewalt, and it's my job to help construction business owners and leaders maximize revenue and turn their businesses into well-oiled machines. We've got a great interview for you today. This is with Gerry McCaughey of Integra. They are a fully integrated off-site solution provider. We're going to talk more about that. This is a potentially provocative, it may even challenge some of what you believe to be true, because we're going to talk about the fact that we don't really have a skilled workforce shortage, at least in the residential framing industry. So here's what we're going to talk about. Here's what you're going to get out of this episode. The 7 most dangerous words in the English language. You're going to learn what a fully integrated off-site solution provider is and how it's disrupting the home building industry. You're going to learn what is the difference between a fully integrated off-site solution and prefabrication. There are some differences that I didn't know about that Gerry had to correct me on. You'll also find out about this fundamental problem with the construction industry that incentivizes people to do the wrong thing. This is something that will have to be solved. There's also a mindset that has to change about the way we do work and the level of detail that we operate at. And lastly, you're going to find out about why you need to communicate with your crews like they are machines, and it's not what you think. We're going to get to that interview in just a minute, but I do have a few resources that I want to get into your hands that will help you take your business and your operation to the next level. The first is a free video series for construction business owners called The Secrets of Successful Contractors. You're going to learn about this different way to operate. You're going to learn about the difference between symptoms and problems, how a lot of what you think are problems in your business are actually symptoms, and how you can get to the bottom of that. To get your free video series, all you have to do is go to constructionleadingedge.com/owner. Fill out the little form there, and I'll email those free videos to you. Also, if we're going to talk a lot about the productivity issue and the skilled workforce problem we have. If you want to get some productivity tips for your business, if you want about a dozen or more, probably more than that, practical, proven tips for increasing your crew's productivity, then you should go sign up for a free trial of my Construction Business Accelerator program. It's an online training program. You're going to get the Crew Productivity Booster, plus you're going to get a whole lot of other stuff, and right now you can get it for free. All you have to do is go to constructionbusinessaccelerator.com and sign up for a free trial of the Construction Business Accelerator. There's a 10-day free trial that you can grab right now, and you can get all of that stuff for free for 10 days. After that, it's ridiculously affordable, and you're going to get a 10x, 50x return on your investment. It was described as badass to me earlier this week. Somebody said that stuff is badass. So if you want some badass crew productivity booster tips, go grab a free trial of the Construction Business Accelerator program at constructionbusinessaccelerator.com. And then if you have a problem project, if you've got a project that's kicking your butt, or you need help getting around a roadblock with your business, if you own a business and you can see where you want to go, but you just can't seem to get there, and you just need some help getting there, then right now I'm offering a free consultation, a free strategy call. I'd love to get on the phone with you and talk through that, help you get where you want to be. This is for construction business owners. And if you want to schedule your free call, all you have to do is go to constructionleadingedge.com/call. So now let's get to the interview with Gerry McCaughey, and we're going to talk about why we don't really have a skilled labor shortage. Enjoy. All right, Gerry, thanks so much for being on the podcast today. We had a Interesting conversation last week. So let's just jump into it with a potentially provoking, perhaps even inflammatory statement that it's your position that we don't really have a skilled labor shortage, specifically in the residential framing industry. There's no skilled labor shortage. What's the real problem?
That is absolutely correct. The real problem is a process problem. It's not that there isn't enough labor to build the required number of houses. It's just that the amount of labor we have is operating using a system that hasn't changed in over 100 years. And my thesis is there is no other industry in the United States that's in the same situation where you are expecting people to increase their output, but actually handcuffing them by saying that they have to continue to use a process that hasn't literally taken advantage of the technological developments, let alone of the last 100 years, but even of the last 10 years. And I base that upon the fact that if you look at the McKinsey report that came out last year with regard to U.S. productivity, you can quite clearly see that U.S. construction productivity, I know people don't want to hear this, but this is an absolute fact. U.S. construction productivity has declined over the last 60 years. Yet, in the same period of time, let me put that in context, why that's so important to acknowledge is the construction industry is the single largest sector of the U.S. economy. So imagine if it was firing on all cylinders, the benefit that would have for the economy as a whole. But it's clearly not. Now, make comparisons with other sectors of the U.S. industry. You can find that U.S. manufacturing industry over the same period of time has increased output by 1,400%. But what's even more surprising than that is U.S. agricultural productivity has increased by 1,750%, but U.S. construction productivity has been less than zero. Now, how can that? That's the first part. I mean, they say about alcoholism, and we're like getting into that. I mean, the first thing you have to do is admit you have a problem. Well, instead of talking about the fact that we have a labor shortage, we've got to admit, first of all, we have a serious productivity problem, because that becomes the real question. If you see your productivity in any industry going down, you start asking different questions. You don't start simply saying, I need more people. You say, okay, how do I actually increase the productivity of the industry? And that's the real question that should be asked. Not simply, let's keep the same number of people we have at this, seeing a decline in it, and do nothing about the underlying problem, which is there's a decline in productivity. My thesis, quite simply, is that every other one of those other sectors of the U.S. economy, over the same period of time, has embraced technology. It has embraced advances in automation. It has embraced advances in production. It has embraced advances in digitization. The U.S. construction industry has done the exact opposite. And I can actually further bring that out into a worldwide scenario, that although construction itself around the world is not exactly stellar in terms of its growth, yet most of the other countries in the world, if you take the world as a whole, construction productivity has slightly increased over the last 60 years. So, you look at U.S. construction productivity relative to the other sectors of the U.S. economy, but now even look at it relative to construction in the rest of the world, and it's actually declining. So it's quite clear to me that the focus on labor is actually the wrong problem, because it's not going to change the issue that the productivity is going down, because that in itself will say if productivity is going down, what's going to happen is the cost of the buildings we're building are going to go up, because we're not getting enough out per person in what we're doing. And there's no other conclusion that you can come to other than we're using an outdated process. And that's obviously to be seen. If you walk onto a building site today, anywhere in the U.S., you're going to see effectively the same techniques that were used 100 years ago, bar the addition of a hard hat and a nail gun.
Yeah, that's a good point. That's something that I talk about a lot. The drum I beat is that many of the, quote, problems that we're facing in the construction industry are not really problems. They are symptoms of underlying problems, like the skilled workforce shortage, productivity. If you try to treat the skilled workforce shortage by just throwing more people into it, it's sort of like saying, well, we're going to fix our leaky bucket by just pouring more water in it. And
that's absolutely correct, Todd. And that's the only point I'm making here is, and until the U.S. construction industry faces up to that situation, we will have continuing problems with affordability, and also with quality, and potentially I would believe with warranties further down the road as buildings become more complicated. and yet we still avoid using the technological advances. I mean, I sometimes say as well, if you look, 10 years ago, the iPhone didn't exist. So yet today, 10 years later, we don't believe we could do without a smartphone, whether it's an Apple or a Samsung or whatever it is. But yet the construction industry, in those 10 years, hasn't done a thing. You look at any industry and you think that the amazing advances that have occurred in 10 years, let alone 100 years, and the construction industry not alone doesn't embrace them, but actually turns them away and finds reasons to justify why it shouldn't be using them. I mean, the amount of times that I hear framers trying to justify the fact that they can build a house or frame a house as fast as we can frame it to the same quality that we can do it, and then and then even be accused of putting up photographs that have been photoshopped when I'm trying to prove my point, which is, again, to me, is a sign of an industry that's in serious trouble, that it refuses to admit the world has changed and is changing at a faster rate than it has ever changed. And we should be looking around, not at saying where can we get more people, but how can we get more out of the people that we have. That, I mean, it would be even take it within the construction industry and saying, imagine if you said to the construction industry now, no, you're not allowed to use a nail gun on site. You know, you're simply not allowed to use it. How the effect that would have? Well, what I'm talking about is technological advances, and that was a technological advance in its time, is to say to the industry, there are further advances out there now. And when you see that factories and companies like ours are using, you know, German and Swedish automation that can make walls that are 10 meters long, 33 meters long, plus or minus 1.5 millimeters, that are shooting nails at 6 nails a second to precision distances, that can then result in that house going up to plate level in one day, and that's 4 people. Like we've done the calculations ourselves and said, if the industry itself, this is going back to this point at the very beginning, Todd, if the U.S. industry as a whole was to adopt the systems that we use as a company, the increase in productivity that would be gained in the U.S. construction industry would be 504%. There is no labor shortage in that scenario. That's what proves the point. I mean, I'm not making it just out of cliches and hearsay. We've done the calculations. It would be a 504% increase in labor. That means you would have 5 times the equivalent of 5 times the current labor force. There's no labor shortage.
Right. Yeah.
It's an existing industry that's refusing to adopt the technologies that currently exist.
Yeah, refusing, or maybe just not aware. In some cases, people just are doing what they know to do, and when we've done something one way for a long time, we tend to block out any other options and just not really be aware that there are other solutions out there. So let's do this. Let's paint the picture of what would this. And we're going to talk about exactly what your company does and how you're solving this specific issue in a few minutes. But what does this mean for contractors if we can embrace new methods that are out there and increase productivity? Paint the picture for what this means for a contractor. Let's say there's a lot of contractors, a lot of business owners, a lot of project managers who are saying, I just don't have enough people. I need more employees. I need more subcontractors, etc. If they can embrace a new process and fix their labor shortage, their perceived labor shortage with a better process, what does that do for them? How is life different for them when they can start thinking, hey, I need a new process, instead of thinking I need more people?
Well, I mean, the resulting output would be one, you'd end up with a higher level of output with the same number of people, or with a reduced number of people. But I'd argue that given the growth in the U.S. construction industry, it's not about reducing the number of people. It's actually about enabling the people that you actually currently have. So you'd end up with an increase in output from the people that you currently have to a higher quality. And that's, again, I mean, that's the same argument that I would make whether or not you're trying to make a car in your front yard, or whether you're trying to build it under a factory. If you do it under a factory, and we accept that basically everything else that we use in life manufactured under factory controlled conditions is a higher quality. So you end up with more output from the same people to a higher quality in a shorter time frame. And there are two separate issues. One issue will end up with a higher output, but you also achieve it in a shorter time frame. So delays get removed from the equation. And on top of that, it's a safer environment for your workers to work in. So over the longer run, you'll actually reduce your other costs, such as insurance. Then you add to that a reduction in the amount of waste on site. which again impacts both safety and also just the sustainability factor. So you end up with all of those gains from embracing a new way of approaching the construction of a building. So the way I look at it, I can't see how there's even the question of the builder losing anything. He gains all along the way, and that gain has been proven in every other industry. This is not some hypothetical situation. This is like asking everybody who currently makes a product for you that you currently use and saying to them, imagine turning around to all of them and saying, listen, I'm not going to buy your product if it's been made in a factory. And then see what happens to the cost and the quality of those products that you start now receiving. They're all going to decline. You're going to miss getting deliveries. There's going to be problems with it. There'll be problems with trying to make it. And yet that's effectively where the construction industry is. And I'm not saying this from the perspective of something that hasn't been tried and tested. I'm saying this from a perspective that I've been in the off-site construction industry over 30 years. My family's been in it over 50 years. I've lived in Europe most of my life. This is the way homes are built, not just homes. This is the way 4, 5, and 6-story wood frame buildings are built in Europe. The idea that you would stick frame it is such an anathema to a European, he can't even begin to understand why you would even contemplate doing that, because of all those other reasons I've said, because you'll get a reduction in quality, a reduction in output, reduction in safety, and a problem with sustainability. So why would you do it? And why has every other industry embraced these techniques? And yet the construction industry keeps continuing to say, which you referred back to earlier on, is that's the way we've always done it. I mean, I think it was a lady in the U.S. Navy who once said that's the 6 or 7 most dangerous words in the English language. Because if you'd said that about everything else in life, then there'd have been no progress. But the world moves on.
This is true. So let's talk about what you do. You mentioned that you're well, I'm going to go out on a limb here and guess that I'm from Kentucky, but you don't sound like you're from Kentucky. You don't sound like you're from the South. You sound like you're from somewhere other than America. So tell us about your background and tell us about your company, what you're doing these days to try to address this problem in the industry.
Well, I mean, as I said, my time in this industry goes back over 30 years. I'm the CEO of a company now in California called Integra. Previous to that, I was the CEO and co-founder of a company in Europe called Century Homes, which was the largest off-site manufacturer in Europe. We had 5 factories, 3 in Ireland, 2 in the UK, but we exported as far away as Japan. We built houses on mainland Europe, the UK, and in Ireland. We did everything from single family right up to, we did the world's first 6-story wood frame building, which is ironically still never been built in the US, and yet we did it in the year 2000. And as I said, in Europe, although wood frame construction may not necessarily be the most common method of construction, because masonry or concrete block construction is very common also, but where wood frame is constructed, it's always built off-site. No European would ever think about the idea that you would have lumber drop on a building site and have guys come out in a pickup truck and start cutting and sawing and nailing at stuff, basically saying there's no use or no advantage in using off-site construction techniques, because we're generally expected to get a building up as fast as possible with the minimum number of people possible. So if you take, for example, the typical size of a house in the United States is 2,500 square feet. We would bring every single 2,500 square foot house that we deliver to site to plate level in literally 6 to 7 hours every time. That's just the normal way to do it. That's the way it's done in Europe. Today, as we speak, there are thousands of houses going up in Europe, and that's the way they were put up. Today, in California, that's what we will have delivered out to site, 2 of them. They will have both gone to plate level by late on this afternoon. So it's using modern manufacturing techniques to make building more efficient. And that is called an off-site company. We refer to it here as fully integrated off-site solutions, because it's trying to get across to the industry as well that it's not just about the panels. I mean, you hear people refer to panels or components and prefabs, and all of those terms are I mean, it goes far as to say that they detest me because they're not relevant to what we do. They are probably, although we make elements, hard elements such as panels, they are the last part. They're merely an output of what we do. They're probably the last 20% of what we do. It's the 80% up front that we do that brings the value and the process change to the industry that allows the builder to make more profit and allows that building to go up in the period of time that it goes up. It's not the panels per se but it's actually looking at the building and the construction and the process and the people involved, and that includes the plumbers, the electricians, the HVAC, the builder himself, even the city inspectors, going back to make sure that everybody fully understands that there's a new process going on, and we're all going to integrate together, pull ourselves from a point of view of we're going to stop using the expression that gets worked out on site to saying that's going to get worked out before it ever goes to site.
Got it. And when we talked initially, I'd used the term prefabrication, and you said, no, we're not like that at all. And a lot of people listening are probably like me, thinking, oh, at prefab, they prefab wall panels, they prefab roof trusses. Yeah, I get it. But really, what's the difference between prefabrication and what you call fully integrated offsite construction? Well, you have an acronym, FIOSS, right? What is?
That's it.
What does that stand for?
FIOSS. A fully integrated offsite solution.
So,
and the reason why we use that fully integrated is because we're not what some people refer to in the industry as a dump and run, where people produce panels, they drop them on a building site and they drive off with it. We're not into that. We actually sit as a partner with the builder, and we actually look at all of the trades that are involved. So what we say is we put ourselves in the shoes of the builder or the developer, with the objective which to get that building up as fast as possible with the least resources possible, which is where the name Integra actually comes from. It's a combination of engineering, technology, and the rational use of building of materials and people. So it's all that focus. Now, most of that work to be able to get that building up as fast as possible involves stuff that's got nothing to do with the panels. It involves actually pulling the plumber, the electrician, the concrete guy, the HVAC guy, the city inspectors, everybody together, and going through the complete process and process re-engineering of how the building is going to be built. So we take it from a situation where what you have in the US currently is pretty much an elongated sequential building process where one person doesn't start until the next person finishes, where what we're trying to do is pull everybody together parallel with each other and shorten that cycle time down by the fact that the people are coordinating before they ever hit the building site. And even down to the point that like, for example, with the concrete foundations, we're involved with the engineer of record on that job, looking to see how could we pull out any of the penetrations that are in that slab that would slow us down when we eventually bring the panels to the site, because we're counting everything in terms of minutes, not in terms of days. Like you mentioned, prefabricated roof trusses and prefabricated wall panels. Well, in reality, they on their own may bring some advantage to them. Unless you're going to a full total solution, you're not really going to do enough to change the amount of labor required on the building site. So, for example, when you refer to the prefabricated elements of ours, we do the prefabricated floors, walls, and roof. So, again, I mean, I would argue, and this is where I suppose where I have this issue with component manufacturers. A wall panel on its own really doesn't achieve much. I mean, you effectively run to stand still, because now you're going back. The minute you put the walls up, then you have to slow down to go back and traditionally stick frame the floor. Which that to anybody, I mean literally to anybody, that's a complete nonsense. If it makes sense to prefabricate the wall, it makes more sense to prefabricate the floor. I mean, the whole thing is about leveraging the system, as much advantage out of the system as possible. And again, if you look at just the typical component manufacturers who will make wall panels maybe 12 feet or 16 feet long, and in case of California, most of the time they don't even put shear on them, because they're designing those wall panels so they can still be manhandled on site. Whereas we make walls up to 40 foot long because we'll use a crane. Here, people will think, oh no, I'm not using a crane because it's an expense. We don't see the crane as an expense. We see the crane as an enabler, because we'll then use that crane to lift the floor panels into position, because there's no way they can be manhandled. But by the combination of using long wall panels, which if you take it, for example, if we have a wall that's 40 foot long and guys are making walls that are 12 foot long, they have 3 walls to put in place and line and plumb, and we have 1. So we're way much faster on that. Then we drop the floor panels into position, and typically on a 2,500 square foot house, we'd have about 4 to 5 floor panels. We'd have the floor down in less than 40 minutes, and we're now up on the second floor. Now you multiply that through when you get into multi-story buildings of 4 or 5 story. You can begin to see that we're not just taking days off the cycle, which is what we're doing with with a single family where we're taking approximately 12 to 15 days off the total cycle time, whereas on a multi-story building we're taking potentially months off the cycle time. All because we've used both a combination of a full panelized system, but we've also looked at that building with the builder, the HVAC, the plumber, the electrician, the engineer, the city inspectors, right down to the nth degree at the very beginning, long before we ever went on site. So it's a complete process change. And as I said earlier on, we believe that the panels are only 20% of what we supply. The other 80% is actually in the re-engineering, and I mean that in terms of process re-engineering, not in structural re-engineering, although there is a certain amount of that, but it's mostly in process re-engineering about how you look at the efficiency and the most efficient way to get that building built.
Got it. Makes a lot of sense. Let's shift gears a little bit and talk about what are some of the common misconceptions about off-site construction. What are some things that people, the misconceptions that you're commonly running up against, saying, no, it's not like that at all, or we can actually do so much more? What are those things?
Well, many of those things we've just discussed, which is, you will have people saying that because their frame of reference, and I suppose for us for a company, this is the most difficult thing, is we get categorized with component companies who really all they're doing is making short wall panels or roof trusses, whereas ours is a fully integrated system where we have literally incorporated everything that we physically can into that building. So they're focusing on the panels, and yet we're focusing on the engineering and the process re-engineering of it. So we have a lot of work done that enables all of the other trades that operate off that building to be able to complete their work much faster. And I'll give you, I won't name the builder, but I'll give you this snippet of information. So we started a rather large U.S. home builder on our system a number of months ago. And we were explaining to him that we'll take about 12 to 15 days off his current direct framing cycle time, which he said, okay, I can see that, because he'd come out and he'd watch us put up other houses and said, okay, I can see that. But our argument was, we'll cut another 12 to 15 days off the total cycle time in addition to the 12 to 15. So about a month we'll take off the cycle time. And he said, I can't see it. I don't understand it. But the 12 to 15 days off the direct framing cycle is something that I want to see and I want to take advantage of, but I can't see how you're going to take it off the rest of the cycle. So 2 weeks ago, in a meeting with him, he told us that he's actually now predicting that he's going to take 45 days total off the cycle time, simply by moving to our system. And part of that was because of the fact now that he's able to compress his scheduling on that job where he couldn't do it before, because he doesn't have to now try to predict and allow a couple of days factor of safety before he brings in his next trade. So if he's saying, I'm going to be finished framing the building on a Tuesday, he's not sort of waiting till the following Monday to bring somebody in just in case something isn't done. Because when we say to him, if we deliver on Monday morning at 9 o'clock, by Wednesday evening at 5 o'clock, that house is ready for the next trades. He knows that on Thursday morning at 7 or 8 o'clock, he can have his trades in there. So he's pulling all of that time back that he was basically leaving as a factor of safety before bringing anybody else in to the equation, because of the certainty of the cycle that we're bringing to it. But now what he has found is that the other trades who are actually coming into that house are now completing faster than they were before, because we've done all the work up front. We've done all of the layouts for the HVAC, for the plumbing, for the electrical. We've sat there beforehand and put that time in before it ever got to the site. So this thing again of it'll get worked out on site doesn't need to take place, because it's got worked out before it ever went to site. Because remember, before we've ever gone on to site with any of these buildings, we've produced a full 3D model of that building. And that doesn't matter whether it's a 1,000 square foot single story building or whether it's a 4 or 5 story multifamily building. We have a 3D model built of that building. We know where every stud is in that building. We know where every post and every beam is in that building. We know where every nail is in that building. So the idea that anybody's having to try to work something out afterwards is gone from the equation. But the sheer quality of the frame and the sheer fact that every frame will be exactly the same, regardless whether it's the first house or the 20th house, means that the trades themselves get more familiar on how to get through that house faster, because they're not having to worry about, oh, it's a different framing crew in this one and they're going to do it a different way. We're going to do it exactly the same every single time. On top of that, if the builder is able to give us where he wants all his blocking pieces in for whether it's whatever item he wants to screw to a wall, we can put those in the factory, so there's nobody going around on the site trying to pick up with those. They're already done. We're using far higher quality material on far higher quality machines, which means the amount of shimming or shaving that has to be done on studs is significantly reduced. So overall, now this builder is saying himself, not alone is it the 12 to 15 days of the framing cycle, it's an additional 30 days on top of that he's taken off the cycle. And this is where, I mean, a lot of our competitors or a lot of people who in the industry want to try to run down offsite construction and say, oh, it's more expensive. Well, remember this. Every single day on a building site to a builder is costing them money. So to the extent that we can help that builder shave days off his cycle, we're saving him money. Now, you can argue over the amount of that saving, whether that saving is $200 a day or whether that saving is $1,250 a day. And I've heard both extremes. We tend to use a figure on average of $800 a day because that was produced by a report that Glenn Cottrell of Ibicus produced, where he analyzed the top 15 U.S. home builders over a 5-year period and came up with that figure. So we use that figure as basically saying, if we save 10 days off, that's $8,000 that builder saved. If we can help him save 3 times that amount, that's $24,000. So it's not, again, this comes back to this thing about first cost versus total cost. I mean, where is the value being created? It's not just simply looking at the cost of what we bring to the site. It's a matter of looking at what the cost of we bring to the site and how that unleashes hidden profit that's in that existing building that the builder is now able to get his hands on again because of the process re-engineering.
Yeah, that's a good point. One thing that may not be so apparent is there are some costs associated with time that contractors are dealing with. One is the carry cost. There's a finance charge if you're using any sort of financing for the project. You also have your general conditions cost, all of your overhead that's associated with that. If you have supervision, project managers, etc., that cost is all directly connected to time. And then there's the opportunity cost. The faster you can turn
Correct.
your backlog into revenue, or in other words, the higher the output of revenue of dollars per day that you're putting in place, then you're reducing that opportunity cost. So I want to get back to total cost versus first cost, but there's a lot of people listening who are saying, well, you know what, I'm not in California. I don't build residential homes, but I do build stuff. So let's talk to those people a little bit. You mentioned that you've completely re-engineered not only the building, but the process. So what are some of those changes in the process that you've developed that would apply to residential construction, whether it's, let's say it's on-site construction, concrete construction, something other than that which could be constructed off-site? What are some of those key process engineering changes that you've come up with? I think one of those, maybe it's a mindset change, is this thought of, well, we'll just figure it out on-site. What I'm hearing you say is that has been removed from the equation. But what are some other engineering process changes that people can apply that you figured out?
Well, I mean, that's the first and probably overriding factor that we have to change, Todd. I mean, that's what people in this industry in the United States come into every project with in their heads, that they'll be able to work it out on site. That'll get figured out on site. And so I don't want to just walk away from that too easily. First of all, I mean, that is absolutely singularly the biggest problem that we have, that people actually have that approach to things. It'll get worked out on site, which we say internally to ourselves means, I don't know. I mean, that's effectively what that means. I don't know. So you have that situation that we have to get people to realize it's not a matter. Yeah, you can work it out on site, but you shouldn't have to. It should always be, you should be able to work it out before you ever build it. You've got drawings. You've got an architect. You've got an engineer. What's so hard about trying to figure out the problem? Every other industry has to do it. I mean, Apple doesn't make an iPhone and figure it out afterwards. I mean, BMW or General Motors, anybody else, don't start figuring out what they're going to do with your car after it's been delivered to your house. It's been figured out beforehand. There's no logical reason in this day and age where the technology exists for that mantra to exist. And all it's doing is extending the time involved to build the building and potentially allowing people to get away with lower quality work than they were being paid to do in the first place. At this day and age in 2018, that mantra should be gone. So I think that's the starting process in it. I mean, the other issue that we have that's been the hardest, probably in terms of process re-engineering, is getting the architects and engineers to understand, and particularly the architects to understand, that dimensions matter, and you need to put enough dimensions on the drawing, and the dimensions that you put in the drawings need to be accurate, not to the point of where people will put dimensions on drawings and saying, and again we've had this, oh, that one will get changed in the field. I'm coming from an environment in Europe where if you put a dimension on a drawing, then that is the actual dimension. And one of the things that infuriates one of our guys in particular, it's been driven into me now, is that they'll show a distance between two walls of 5 feet where there's a bath fitting in between them. But the actual dimension is 5'1", but they'll show 5 foot. And the attitude when you spoke to the architect is, oh, well, the framer on site knows that. I mean, that's such an anathema to us, coming from the precision that we come from, that it's hard to even believe that that's actually stated. We also had a trouble on another drawing where we were asking a builder or an architect to confirm with us what the actual ceiling height was. Was it 9 foot dead, or 9 foot and a quarter, or 9 foot and a half? And the architect's response back to us was, well, we really only draw to within an inch, so if it's 9 foot or 9'1", it doesn't matter. I mean, that is just, that to me is incredible, that in 2018 that's the way things are being drawn. Because when you run, and this is where it causes the difficulty for us, but also, again, it's the opportunity that we have, because why we bring such precision to the equation. Because we can't put a drawing, remember, we take a drawing and we produce a CAM file, a computer-aided manufacturing file that we send to a machine. The machine can't interpret anything. It can only take the data that's in the file. So the data that's in the file has to be accurate. So again, this is where it's going back to, it gets worked out in the field. It can't be. It gets worked out before it goes through that machine, because that machine can't work it out any other way. So we're having to go back to the architects and engineers saying, we're sorry, but the dimensions that you have in the drawing need to be absolutely accurate to 1/8 of an inch. What is that wall distance? What is that wall height? What is that thread depth? We need to know exactly what's going in there. Not that it's going to get worked out on site, because we're going to run this through automated machinery. The benefit of running through the automated machinery is that automated machinery will make the exact same thing the same way every time, to a far higher output and a far higher quality than could be achieved by manpower on its own. But it can only do it if it has the accurate dimensions to allow it to be put into the computer program in the first place. And so getting people to understand, when you provide a drawing to us, either you're going to have to put the accurate drawings on it, or we're going to waste time going back to you asking you these questions. But we're going to go back and ask you. And that's, I think, some of our builders have found, and it's really been an enlightening experience for them, because they're actually saying to us, you know something, you're absolutely 100% right. We're paying for these dimensions to be on these drawings, but the architects are not doing it, because they're relying on the guy on the site to get away with it. I would absolutely say to you, if you get a drawing from an architect in Europe, the dimension has to be accurate. Here, literally that expression, it get worked out on site, is the one that's thrown out. It cannot be. And that's, from an off-site production perspective, that's one of the key items that has to be overcome. The dimensions have to be adequate, meaning there has to be enough of them, and they have to be accurate.
Yeah.
But we will as a company keep coming back looking for them. But the fact that we're looking for them is only delaying your project, and it also means you're paying twice for it, because we're charging you, in some way or another, we're charging you time to get that right. But getting the architects to do it right in the first place would be a major advantage.
Yeah, I see this so often, and it's an accepted part of the process that whether it's in commercial or residential construction, there's the two words that most contractors hate: field verify. And for example, rough openings for windows. Well, the architect will have, the drawings will have some opening, some approximate opening size, but if you want to frame that window, you actually have to look at the rough opening on the shop drawings. If you want to frame for a fireplace, if you want to install a storefront window assembly or a revolving door on the front of an office building, your building typically you're constructing it from some montage of 8.5 by 11s and emails and cut sheets, and so it's unfortunate, but it's accepted that the drawings don't have all the information that you need. So one of the things that I teach in the Construction Business Accelerator, and I work with my coaching clients on, is I tell them, hey, every decision is going to be made at some point on a project, whether it's a window rough opening, the thickness of drywall, the ceiling height, the concrete reinforcement, whatever. Every decision is going to be made on site. It's going to be made at some point. You get to decide when that decision is made. So what I'm hearing you say is, we're going to make every decision, if you want to do it efficiently, we're going to make every decision when we're talking about lines on paper or digits in an electronic file. And unfortunately, so many people just postpone, and they allow the decisions to be made when there are people standing around, general conditions are being incurred, equipment standing around, labor is being lost. Well, we'll figure it out when we get there. And so I agree that is it. Before we start hiring more people to try to fill this void, this perceived skilled workforce problem, whether you're a candidate for fully integrated offsite system or not, you have to address your process, and you have to package up. I think that a great mantra would be, before you have somebody build something, you assume that a machine is going to build it, and that they are not interpreting, that they're not looking at bathtub shop drawings or revolving door shop drawings. They actually have the information to build from, without having to interpret, without having to extrapolate, without having to have some years of experience. What else? What are some other process engineering changes that could be applied to other types of work? Let's talk about commercial specifically. Most commercial projects are not stick-built. They're not typically candidates for offsite construction. But what are some process engineering changes that commercial contractors can take advantage of?
Well, I mean, to be fair, from what I understand from the commercial side of the U.S. industry, it has actually, I suppose, changed and adapted and made major improvements. This is from what I'm hearing anecdotally now myself, Todd, from other people from customers of ours who operate in both environments, and they're saying that in the commercial side of things are a lot better than they are. And I give you examples would be, for example, and we had this now recently, where there are 12 slabs in the ground for us to go and put our frames up on. And when the last number of frames went out, it appeared that the plumber had put the pipes penetrated the slab in the wrong positions. Now, we had given him every single detailed drawing dimension that he needed to put them in the correct place. But it appears, and we've been out on site, where the plumber, when he's putting his pipes in the ground, really when he was walking the perimeter of the site, he was basically doing it by line of sight, by visually positioning it. He didn't take a tape out of his pocket. The only time he took a tape out was when he had a penetration that was in the middle of the base, and he was trying to take an accurate dimension from the edge of the base to the center of it somewhere. But as it went along the perimeter, he was just doing it by eyeball. And trying to get people, the trades on site, to understand that's not adequate. That is not sufficient. There is a dimension on it. So we're back to the dimensions and they're not being adequate. But when there is a dimension on the drawing, you need to use it. It's there for a purpose. I mean, the old carpenter's maximum, where did it ever go to? Measure twice, cut once. Where did that ever disappear to? That's how you solve a lot of these problems. If you just simply measure, I say that if you, sorry, I know I'm jumping back now to residential, but I say that the construction industry really has certainly the residential industry has set itself up to fail at the very beginning of a process. And what I mean by that is that if you typically take a concrete slab that's put in slab on grade and it's put in the ground, generally the most that the builder does to check it is put some water on it, see if it's ponding, and then he'll get it ground down if it's not level. But in reality, there's very little done about the overall accuracy of the dimensions on the base. If it's a little bit out, it's a little bit out, and they leave it that way. And then what happens is the framer arrives on site. Is it in the framer's interest to report back to the builder that the slab is off when he arrives there with his lumber pack? No, because he's incentivized to get that house up as fast as possible, because He only gets paid when he puts it up. So here you have a situation where the slab could be out and the framer's going to put a frame on it regardless. And all our mothers have told us 2 wrongs don't make a right. But at the very beginning of a process, there's 2 wrongs that people have basically operated on because both parties are not incentivized. Well, first of all, the concrete guy has never been penalized before to make sure that he puts his base into an accurate dimension. And the framer, when he arrives on site, all he wants to do is get that building up as fast as possible so that he can get paid. Then you add the third piece to the equation. If the lumber pack that's delivered to the framer happens to have substandard material in it, is that framer going to send that material back and potentially be delayed while he puts that house up and then not get paid? No, he's going to incorporate that material into that frame because he wants to get paid. So you have a process that starts with the concrete guy, the framer, and now you could argue the plumber, who will literally go ahead and continue to put that building up regardless of the fact that it may not be in conformance with the drawings, because they're incentivized to do that. In other words, they're incentivized to do the wrong thing. So my argument on that is this is where you go back to the thing, why does it take so long to get a house built? Well, if you don't have speed comes from accuracy. As most people think it's the other way around, but if you give precision and accuracy in the drawing, it allows every other trade that works in that building to get in and out of it faster. They're doing less cutting, they're doing less measuring, they're doing less scribing, they're doing less shaving and shimming. Everybody can get in and out of it. If that frame is put up exactly as it's supposed to be, with angles exactly as they're supposed to be, then everybody else who gets in and out of it can operate much faster. But what you have here is a system that's invariably set up, fail is too strong a word, but it's set up not to incentivize quality. It's set up to incentivize just keep on going. And so, to the extent that we're trying to get people to fully understand here, every action will have a reaction. And therefore, you have to start at the very beginning and get accuracy in everything that you do. And this brings me back to the slab. Like, one of the things that we heard when we started off here first was, oh, you're going to have a lot of trouble with all the penetrations, particularly in California, because of the seismic conditions, which is going to slow the process down. And also, we found out that part of the reason why the concrete guys were having trouble getting their slabs level was because they were going in and having to hand trowel around all the J-bolts and the penetrations that were in the slab. So we went to the engineers and said, listen, is there another solution here which says that we don't have to put these penetrations into the slab because it'll allow us, one, to get our frame up faster. We won't have to stop as much on site to start drilling to accommodate the holes. And two, will it allow the concrete guys to get a much more level site, so therefore there's going to be less chance of the frames being off. And the engineers come back and said, sure, there is. There's a multitude of different ways, different solutions to it. So we basically then engineered all of the slabs to take out as many of the J-bolts as we could take out, so as to enable the plumber, the concrete guy, to get a much more level slab and allow us to put the frame up as fast as possible. And there was a very simple thing that has been going around for years saying, oh, you can't do it, you can't do it. And yet nobody had asked the question. Of course you can do it. And people say, well, it's much more expensive to be putting these bolts in afterwards. Well, actually, it's not, because you'll get a credit off the concrete guys, because they're pouring down 12 different slabs. I can tell you they can get through those 12 slabs an awful lot faster by the system that we've now given them compared to what they were having to do with all these J-bolts. So it's just a lack of thought in the process that people were continuing on to operate, basically saying that's the way we've always done it.
Yeah, one of my favorite questions is always to ask, is there a better way? And the answer is probably yes. So a better question would be, what's a better way to do this? Even if you don't know what the answer is, but to ask, what's a better way to do this? And in my experience, the people who ask that question consistently are the ones that have a lot of success. So let's get back to this concept. I want to make sure we talk about this before we wrap up. We're running short on time. Talk about the difference between total cost and first cost and how people should be thinking about that in their projects.
Well, I mean, a good example is the one I said to you before, is if somebody looks at a proposal from us and it's, a framer's charging, take a figure, figure's charging $40,000 to put the building up, and we're charging $42,000, just to pluck figures out of the air. It appears we're $2,000 more expensive. But then you have to factor in, and this is just a very simplistic way of doing it, but you have to factor in, we're going to take 10 to 15 days off that cycle. Now, let's just say it's 10 days. So 10 days by 800 is $8,000. So in actual fact, when you look at the total cost, instead of us being $2,000 more expensive, we're actually $6,000 cheaper. And that's a very simplistic way of actually putting it there. But that's the truth that people, the current industry, when they look at it, and again, by the way, I think a lot of people are incentivized. If you have buyers who are incentivized to buy the widget this year at 0.5% cheaper than they bought the widget last year, but they pay no hindrance or regard to how difficult it is to put that cheaper widget into operation and how much more time it'll take on site, then bad decisions get made. You have to look at the total cost and the total impact of the decision that you're making that it has on the total project. And so getting people to realize that off-site construction is not more expensive most of the time, but even where it is, you have to have the trade-off of what the cycle time reduction is going to have in your overall costs. But then even on top of that, like from our perspective is, we basically, at the end, when we put a house up to plate level on the first day, you couldn't fill a domestic black bin with the rubbish that we have left over. So the builders are telling us that there's between $400 and $800 of savings on trash alone at plate level on the first day by using our system. Then you have to look at about the total cost is, what would that allow you to do? If you've got a project manager on site and you've got multiple sites, can that project manager now, because of the efficiency of our system, can he now manage 2 sites instead of 1? So now you can put his total salary, you can amortize his total salary over 2 projects instead of 1. So if he's getting paid $100,000 a year, it's no longer being $100,000 applied to that one job. It's $50,000. So it's looking at the total cost and the impact that a system like ours would actually have overall of the total project, not just simply the first cost. Here it is. You cannot simply ignore the advantages. There's an advantage to there's a cost benefit to all the advantages we bring, whether that's a cost managed because of speed, whether it's because of less waste on site, whether it's because of better safety on site, or whether it's because better quality on site, or the last one I'll say is because of the fact that you now can actually bring customers out and bring them to that site and let them walk through it and let them see the site across the street that's being built. It looks like it's hard at times to determine whether or not the house is being demolished or being rebuilt. There's that much waste lying around it. To actually walk into a site that's clean and efficient, because that says something about the builder to that client. So you have the ability to use it as a marketing tool as well. So what's that worth in terms of a benefit to you? So it's just not simply the upfront cost, it's the total cost. And I mean, we've said this over the years in Europe when we were doing this. And remember, we were doing about 8,000 houses a year in Europe. One of the things that we realized over that 30-year period that I was involved in is that we never lost a customer. But most of our customers would actually tell you years later, it actually wasn't simply the cost benefit that was the reason why they were staying with us. It was because of all of the other things that they couldn't see on day one that actually meant that they felt far better dealing with us and had a far more professional way of running their sites. In fact, one of them said to me, "You guys are like an octopus. You get your tentacles into us, it's very hard to get away because we become so reliant on you because you're doing so much for us. You're helping us with our waste. You're helping us with engineering problems. You're helping us with thermal performance. You're helping us find better ways and better products to put into this house." We had no one person to go to before to do this. We were having to go off to this person, that person, employ an engineer, employ somebody there. Whereas all that resource is actually within the offsite company. And again, that's a major difference between an offsite company and a component company. We offer so many other services to our customers. Like, I give you an example that we're building the show house now for KB Home at the International Home Builders Show in Las Vegas, which will be going out in February of next year. And we deliver that house to site pre-insulated. It's actually insulated with phenolic insulation. So when the walls were stud, the house was already insulated. That's the way we've been doing that in Europe for the last 15 years. That will be a product innovation we will bring to the market here when it gets more used to currently what we're doing. But imagine that when your house is stood on day one, it's actually all insulated. We can do a lot more in terms of bringing value add to the product that we're currently not doing, because we're only now trying to get the market to understand and utilize a very simplistic offsite solution. But all of the other advantages and innovations that are there and have already been tried and tested in Europe are already available. And actually, a funny story about the insulation. When I said that before, about a year ago, that we were going to do it, a framer who came on and LinkedIn and decided to insist to me that he had so much more experience that I didn't know what I was talking about. Saying you'll never be able to do that because you have to have four-way support for the installation of the cavity. And I just simply referred him to the California Factory-Built Housing Code. I said, you realize you can go here and actually get your systems approved. And again, this is another indication of these people who sometimes think they have more experience than everybody else on the planet, yet they've never looked outside the confines of their own blinkers to realize there are different ways to do things. And by the way, the world has been doing them for the last 30 years, which brings me back to this situation of when you say that there's a labor shortage, there isn't. It's quite clearly a process problem because people are refusing to change from what they've been doing for the last 30 years.
Yeah. Well, let me challenge you with this. Let's say that you have been brought on board on a commercial project. This is a steel frame building. It's a 4-story steel frame building, 60,000 square feet, and concrete decks, not a stick of untreated lumber in it. And you were brought on to implement some of the process changes and streamline this project. And let's say you were challenged to take 2 months off an 8-month schedule. Where would you start? What would your thought process be, and how would you attack that?
Well, the first thing I need to know is this building that you're talking about in any way panelized as this? Or are you talking about it's going to be framed on site?
Well, let's say the exterior walls are metal studs and masonry is what it's designed for. Metal stud framing, masonry exterior, punched window openings. Yeah, that's how it's designed.
But the walls. No, but are the walls being? I'm sorry, Todd. But are the walls being stick framed on? Are the steel studs being made into walls on site, or are those coming as panels from a factory somewhere?
The design doesn't say. The design just the wall sections just show.
Okay. Well, the first. Okay. Well, just so you know, so we're pretty familiar with doing large scale commercial steel frame buildings in Europe as well. In fact, I'll give you an example. We did a project in Dublin where the client in Dublin, and again it varies from market to market in Europe. In Ireland, you couldn't go more than 4 stories, whereas in the UK you could actually. In Scotland you could go 5, in the UK you could go, or in England you could go 6, in Ireland you could go 4. But the builder wanted to go 5 stories, and the block contained a 5-story central core with 2 4-story wings. So we engineered the building to have a central core of 5-story steel frame with 2 4-story wood frame wings, and actually calculated the differential movement between the 2 buildings and came up with the detailing to allow the 2 buildings to be built with a complete external skin of masonry and allow the buildings to move, including moving past the windowsill openings on the building. So it's something we're very familiar with. But in those buildings, in the steel frame buildings that we always did in Europe, first thing we would say to you is we would be making those panels in the factory as the slab was being poured on site. And as each floor is going up, we'd be making the wall panels for that building in a factory, so they could actually be delivered to site and set as fast as possible. Depending on whether the floor itself had a concrete deck on it, if you're using a concrete pan, well then that will actually pretty much have to be set on site. If you're using a steel floor joist, we would then be making those floor joists, so that floor panel in panels in a factory and craning into position. But the wall panels themselves would be coming out the way we did it. We would be bringing those wall panels out insulated on the exterior of them using polyiso or phenolic and taping them in the factory, so that whenever the walls are actually going up, the walls are actually insulated and the cold bridge has been taken out of it, so you can directly fix your masonry to the outside of it. And so we would be still attempting to achieve. And in terms of doing that, whether it's stick built or whether it's being used in our system, we'd easily take 2 months off that equation. Easily. By the fact that we're able to use factory assembly and the factory application of the insulation on the walls before it ever gets to site.
What about interior metal stud framing? Would you ever stick build those on site, or would you panelize those as well?
Never. Always panelized.
Panelized off-site? Okay.
Off-site. Always panelized off-site. When we deliver to site, it's actually delivered on the trailer in sequential reverse order. So as you take it off, you're putting it into position. Now you can, if you want to get the trailers away, you can lift the panels off in sections, drop them on the ground. But in many cases, we're moving them so fast off it, it's actually as simple just to start craning off the back of the truck and put them into position.
And how much work would you do in the factory? Would you be installing electrical outlets and whips, or just panelizing walls? How far would you go?
No, we would just, in that case, we'd probably just panelize the walls and insulate the external walls. Now, obviously, the walls are drilled, or the studs are drilled to allow the electrical penetration. But no, we wouldn't be doing the electrical in the factory at the moment. And primarily, the reason why we've discussed this a lot ourselves, and the issue that we have here is that when you're trying to take a market that's still pretty much, I know the commercial is slightly different, but you're still trying to take a market that's primarily a stick frame market and move it away to an off-site solution. The builders themselves and the developers have a certain risk aversion that when you're trying to take too many away of the trades that they're familiar with, they see the risk profile increasing. So our way of looking at this market has been initially is to try to get them familiar with the system. Then once they trust you, then you have the ability to go back to them and say, listen, we can add more value to this by doing these additional pieces of work to it. But as opposed to trying to push it all at the one time and having them question whether or not they feel comfortable with that risk profile.
I think that's a great approach. Start small, develop trust, and then go back and say, hey, do you want to see what else we can do for you? Good stuff.
Correct.
Great. Well, this has been an interesting conversation, very enlightening. The main takeaways for me would be it's unacceptable to say the words, we'll figure that out on site. That's just not going to work. So my challenge to everybody listening would be to look at your process and eliminate that possibility. Assume that you're feeding information into an automated machine and eliminate the need for interpretation, looking at multiple sources of information, package your projects up in such a way that your people can look at the drawings and build and not have to do anything else. So I really appreciate this, Gerry. If folks want to find out more about your company or get in touch with you, what's the best place for them to go to do that?
Our website is entekra.com, entekra.com, and my email, which I'll give out, is very simply, it's Gerry with a G, Gerry, at entekra.com, and I'll be happy to respond to anybody that I can.
Fantastic. One last parting shot. You've got an audience of construction business owners and leaders, project managers, superintendents, who are obviously interested in developing themselves, and they're interested in making the industry better. That's why they're listening to podcasts like this. What's one thing that you would want, one message that you would want to get out to this group of people?
It's pretty much the same thing as I've been saying, I suppose, is that, or I'd say, put it this way, I think we all need to move away from the idea that of this statement, that's the way I've always done it. I mean, I think that lady who worked for the U.S. Navy, and she said it's the 7 most dangerous words in the English language. I genuinely believe that's true, because there would be no progress in any field, medical, whether medical, transport, construction, anywhere, if people continue to think that way. So I think that is, I mean, the Irish Times, which is an Irish newspaper, actually, probably this is the parting shot that I would leave on this one, Todd, is an Irish newspaper, the Irish Independent, has a strap line that says, before you make up your mind, open it. And that's what I would say to people.
Good stuff. Good stuff. Well, thanks so much for taking the time to be on the podcast. I really appreciate it, Gerry.
Thank you, Todd. Much appreciated.
To get all the links and the notes and the resources we talked about, go to constructionleadingedge.com/088. For the show notes, you can find Gerry's contact information there, links to all those free resources that I want to get in your hands, which include a free video series, The Secrets of Successful Contractors. I also want to get my crew productivity booster in your hands, and that's part of the Construction Business Accelerator that you can get a free 10-day trial for right now of your very own at constructionbusinessaccelerator.com. And then if you want to get on the phone with me and talk about strategy, then go to constructionleadingedge.com/call, schedule your call, and I'll go one step further. If you want to get in touch with me and you can't remember any of that stuff, then do this. Give me a phone call, shoot me a text to this number, 859-667-2015. You may be thinking, this is a joke. There's no way this guy's going to answer. Try me. I dare you to text me or call me and see what happens. 859-667-2015. I talked to a guy last week, and he's like, I can't believe you give your phone number out. And I do. I want to help you guys, and if getting on the phone will be the best way to do that, then take me up on it. I dare you to try it. That wraps this up. Again, go to constructionleadingedge.com/088 for all the notes. And as always, I appreciate the ratings and reviews on the podcast player of your choice. If you could leave a rating or review, I would greatly appreciate it. That helps get the word out there to the rest of the interwebs about the podcast. And as always, thank you for listening. I'll see you next time.